this session, I'll talk about the process of value at risk mapping, especially when we are dealing with a portfolio which consists of several types of assets, asset classes, right? How do I map all the various positions of different kinds of assets to their corresponding risks, so that by segregating the various positions into based on their various risk factors, analyzing the overall risk of multi-asset portfolios becomes very much easier. So generally, for computation of market risk, especially for a portfolio containing various asset classes, what is generally done is the different positions associated with the portfolio are taken. The different positions associated with the portfolio are taken, and each position is mapped to a specific risk factor. Probably that specific risk factor could be something relating to change in interest rates. What is the kind of impact that this particular position has with respect to change in interest rate? What is the impact this particular position has with respect to change in equity index? Probably the bonds are very much impacted with change in interest rates, but the equity assets which are there in the portfolio, they are equity indices. Probably the equity securities that are there, equity positions that are there in the portfolio, they are very sensitive to equity indices, or probably some kind, or any derivative securities, derivative positions that are there, even depending on what is the underlying. Probably if the exchange rate is the underlying, what is the changes in the exchange rate, and we are trying to see how is this position impacted with the changes in the exchange rate. So typically we are taking the different positions and trying to map these positions with respect to the various risk factors. These are what we are calling as the risk factors. So we are identifying some common risk factors. So in this typical process, what we are doing is we are identifying some common risk factors like interest rates, equity indices, exchange rates. They could be macroeconomic factors, but these are all the risk factors because they are impacting the positions. So we are taking a list of risk factors in the portfolio and trying to map the positions. So that way, what could very well happen is we are reducing the number of variables. By reducing the number of variables, we are simplifying the risk management process. And I can even evaluate the characteristics which are changing over time. Probably the positions keep changing with time, right? If the interest rates have gone down, probably the value of my bonds in the portfolio is going to go up, and vice versa. So the various characteristics of the various positions which change with time, that could be understood much better. And at the same time, even for some kind of investments which don't have any history, even they could be, the risk management of them can be analyzed quite comfortably using this kind of a mapping procedure. And majorly is we are trying to cut down on the number of risk factors because We have identified a common risk factor set, which may be hardly 3, 4, 5, not more than that, and trying to map the various positions to these risk factors. So the process is getting very much simplified, and once the mapping is done, and the actual returns of the portfolio are computed. Based on that, the distribution of the returns is assessed and the value at risk is computed by understanding the distribution of the final overall return. So here the point is, this entire process is position based. It's not a return based mechanism. I'm not taking the historical returns of the securities and based on that trying to derive the VAR. I'm not doing that. I'm going with the change in the positions, which is much better than the return based one, because the return based one is not able to incorporate the change in position. Probably I may have sold off some of the securities or some units of a particular security, or I might have purchased additional units of the securities. I may have taken new positions recently. I may have closed my existing positions recently. So that kind of style change or my composition of the portfolio change is not getting incorporated as a part of the return based models, whereas the position based models are able to incorporate those kind of stuff. So basically, in a return based, there are a lot of hidden risks, because I am computing, let's say I am looking at the historical returns of a particular asset over a period, trying to compute the VAR or something based on the historical data. But it may so happen that up to this point I had 20% of my assets, 20% of my investment in this security, whereas here I made it 15%. So this change in the positions is not being taken up, so which means there is a lot of hidden risk in the process. So, and especially one more thing that goes, especially with respect to, let's say, we are talking about low frequency, high severity kind of events. Low frequency, high severity kind of any event. As long as the event does not occur, it looks as if there is a lot of consistency in the returns across the period. Right? Let's assume that in this last 1 year there is not much of an occurrence of this particular event. It looks as if the returns are very much consistent using the return based model. But the moment this high severity event occurs, suddenly there is a big change in the return. There is a big change in the return. So which means from a volatility dimension as well as from a return dimension, there is a lot of inconsistency associated with these kind of models. So from every dimension, it is understood that position based models are always much better off compared to a return based model. But yeah, understanding the various positions of hundreds of assets in a single portfolio could be more expensive and requires a lot of time consuming, and even more resources are required to understand the process. So from that, and probably the it is completely based on the goodness of the data that is used as the input. So model risk and all might very much crop up because of the inaccurate use of data or the model specification. So that is one dimension where some kind of effort has to go in if we are using the portfolio, the position based models for the evaluation and computation of the market risk. So for everything, let's say when I talk about the bonds, probably I will look at the change in interest rate as a risk factor. From the bonds perspective, okay, the change in interest rates is the risk factor. And what is the exposure to that? probably I'll look at duration as the exposure to the change in the interest rate, probably duration or modified duration, some measure which is more closely related to change in interest rate. Probably the same way when I'm looking at equities, I'll look at change in the index. And the factor that is talking about the sensitivity to the change in index, let's say, is the beta factor, which is a measure of, which is a common factor for all the equity securities. Like that for everything, okay, change in exchange rate. Whatever is the sensitivity with respect to change in the exchange rate, probably for all forward kind of a contracts, I can look out this kind of a mechanism. So then we can simply, when we are looking at if at all the positions are exposed to the same risk factor, so which is if my portfolio is containing exclusively of bonds, so they are all exposed to the same risk factor, which is the change in the interest rate. So there I can find the portfolio exposure as the weighted average of the position factor exposures. But I cannot aggregate it across, means if it is containing the bonds and stocks, I cannot do a weighted average between the bonds factor exposure and the stocks factor exposure, and I cannot add them up. So overall what it is looking out for is I have to identify the various list of common risk factors, identify the exposures with respect to those common risk factors, and of course there are so many other limitations. Okay, even when I say duration is a better measure of exposure with respect to changes in interest rate, we see that at very large interest rate changes, duration is not a good measure of the price, because the rate of change of duration, the percentage change in duration with respect to the percentage change in interest rates, we had a mechanism of convexity. So too much of uncertainty or too much of fluctuation in the duration levels also means if the interest rate is changing quite drastically, then duration is also not a good measure of a factor exposure, especially with respect to the change in the interest rates. Now, depending on how complex our portfolio is, we will have the exposures to various risk factors. So the next question that comes up is how many risk factors are required? Probably if I am just going with one or two risk factors like change in interest rate, change in equity, one or two risk factors, then it may so happen that our position may not be sensitive to these one or two risk factors, means there is a large proportion or large portion that is more associated to specific risk. Company specific, idiosyncratic kind of a risk exists to a large extent. So the lesser the factors are, the higher the scope for specific risk. The specific risk is going to be higher. But if I am trying to increase the number of factors, of course complication increases, because I have to try to find out the correlations between the factors also. So complexity increases, but the specific risk can very well come down. So more risk factors we are taking, a better approximation of the portfolio's risk exposure can be done, and the smaller will be the specific risk factor. So it is a trade-off between the number of risk factors and the residual or the specific risk. Number of risk factors versus specific risk. More the number of risk factors, the lesser will be the specific risk, and vice versa. So if I am just using duration, probably there could be a lot of specific risks associated with each of the position. But along with the duration, let's say I include some other factor like credit risk. Then what could happen is, okay, some portion would be associated with the credit risk, which means in isolation, so the company specific risk that can be associated, the specific risk that can be associated will typically come down. But at the same time, trying to identify the kind of interactions between this credit risk and the duration and trying to link them and trying to work out accordingly would create another additional complexity in the building of the model. So though we are saying in case of a portfolio we are trying to map each position to a set of general risk factors. Having too many general risk factors, though it can reduce the specific risk, but it can increase the complexity of the risk management analysis. So whatever is the specific risk, we generally treat it as undefined. We cannot associate it to a specific factor. That can come down if we are adding more and more risk factors to the typical VAR model that we are creating. Now we have to look at what are the typical mapping approaches that are available for different kinds of portfolios. Probably what is the mapping approach that is available for a fixed income portfolio? What are the mapping approaches that are available for the positions relating to derivatives and all those kind of activities? Alright. So when it comes to fixed income securities, so whatever the portfolio we are talking about, the various positions in our portfolio can be mapped to the risk factors using the three mechanisms. One, I call it as principal mapping, wherein I am trying to map the principal with respect to the risk factors. So whatever is the face value of each of them, the change in the face value is what, or the face value is what we are mapping to the various risk factors. So here the major risk that is involved is the repayment of the principal itself. And this mechanism actually considers only the average maturity of the portfolio. Average maturity period of the portfolio, and probably from this, if I have to compute my value at risk, wherein I am trying to take the risk of a zero coupon bond. Probably the simple way to compute the value at risk here is I am considering the risk of a zero coupon bond whose maturity is equal to the average maturity of the portfolio. Whatever is the risk that is associated with it, we take that as the risk and compute the VAR. The most easiest and the simplest of all the methods that are available. So that is one way the fixed income positions are mapped. Then the other way we can try to do the mapping is based on duration. So here each bond, right, based on the duration of each of the bonds position, it is mapped to a zero coupon bond of that duration. So using those durations and weighted average of those durations, the VAR is typically computed. But the biggest problem that may come out is for some bonds, whatever the duration that comes up, there may not be a zero coupon bond associated with that duration. So what happens is estimating the risk levels become slightly difficult because of that. Whereas the third and the most important mechanism that is used for mapping purposes is cash flow mapping. Now for every bond, we have different cash flows coming up at different periods. So there could be some short positions in the bond, there could be some long positions in the bond for where the cash flows are actually made at different time periods. Now what we are saying is each cash flow of the short and the long, they are decomposed. So this becomes a separate instrument, this becomes a separate instrument. So this cash flow, the present value of this cash flow, I'll try to map it with, let's say, a 6-month duration. Similarly, this I'll try to map it with a 1-year duration. So the zero coupon bond of 6-month duration, whatever is the risk involved, this cash flow is mapped to that. Whatever is the risk involved with a zero coupon bond of 1-year duration, this cash flow is mapped to that. Similarly, probably this is mapped to another zero coupon bond with a 6-month duration. Like this, all the short and long positions, the present value of their cash flows are mapped to those particular risk factors associated with a zero coupon bond of that particular maturity. Then the inter maturity correlations are also considered to finally find out the overall portfolio value at risk. So we are trying to make a more precise way of computing the value at risk, which is a bit more complex compared to a duration based mapping and a principal based mapping, but it is more and more robust also because it is trying to match each and every cash flow with respect to the risk associated with that zero coupon bond of that particular maturity. Correct? So just to summarize this process, when we are talking about the fixed income securities as a part of our portfolio, either I can look at the principal based mapping or a duration based mapping or a cash flow based mapping, and each of them has a different level of complexity. Probably the cash flow based mapping has much more complexity compared to the principal mapping or a duration based mapping. And even from a precision dimension, this is more precise compared to here. There may be a lot of errors cropping up in these two. And typically in this cash flow based, it's a slightly more robust, as we said. Each position, short, long, each position is decomposed based on the present value of the cash flows, and then they are mapped to zero coupon bonds of that particular maturities. And probably if required, the intermaturity correlations are also being considered for the final computation of VAR. Now, in case there is a perfect correlation between the various maturities, right? Probably 6-month and 12-month. If there is a perfect correlation, then probably the easier way is the portfolio VAR. Perfect correlation means if it is equal to 1, then we can very well say the portfolio value at risk is same as sum of the individual value at risk, or the other way to simply put it is this is the same as the undiversified VAR itself, right? So if it is lesser, I mean if the correlation is less than 1, then obviously stressing, I mean as a part of the stress testing, what could very well happen is each of the VAR, each of the individual VARs, it is, when I am doing a stress testing, what we could do is each zero coupon bond of that particular maturity, I can stress it each zero coupon bond of that particular maturity, I can stress it by its corresponding individual VAR rather than thinking of the intercorrelations that are existing between them, especially when I see that the correlation between the various maturities is very close to 1. But if it is much away from 1, then probably there is no other go. I have to look out for the intermaturity correlations that are existing also. But at least in case where the correlations are much closer to 1, we can use this kind of each zero coupon bond being stressed by its corresponding VAR can be quite easier in terms of computing the overall VAR of the portfolio. It's more simpler than thinking of correlations, but of course, if the correlation is very much different from 1, then probably this mechanism may not be applicable for a portfolio. Generally, we also keep hearing a word called a benchmark portfolio. I always select a portfolio which is more or less on the similar lines in terms of risk as my target portfolio and try to compute the VAR with respect to that particular benchmark portfolio. That is what we are calling as benchmarking. I would like to see for my target security or for my target portfolio what is the VAR. I'll try to compare it with that of a benchmark. So typically wherever I am seeing the risk factors more or less similar to that of our target, we create a benchmark. And whatever is the difference between the two portfolios VARs that we are getting, between the one which we are targeting, our target portfolio, as well as the benchmark portfolio which we are considering, the difference in the VARs between those two is what we are calling as the tracking error value at risk. Right? So even the benchmarking of a portfolio is one of the important aspects, because one of the most popular usage of the VAR, especially with respect to this market risk, is we create a benchmark portfolio and measure the VAR in respect to this particular benchmark. Then when it comes to the world of derivatives, probably I would like to see the linear derivatives like forwards or probably swaps, right? In forwards, FRAs or any kind of forwards and swaps which have the linear kind of a behavior. I want to segregate them from a non-linear kind of derivative instruments like your options. In case of linear derivatives, probably the delta normal approach is much comfortable in terms of portfolio mapping, whereas here the delta normal approach is good as long as the deltas are stable. But here we know in case of non-linear, the deltas are not stable, so probably it's better that we go for a delta gamma normal kind of an approximation method, which can be actually going with respect to the usage of Taylor series. And so when we are doing what these linear kind of instruments, we are computing the VAR of the portfolio as nothing but the linear combination of the individual normal risk factors, normally distributed risk factors. We are expressing them directly as a linear combination of them. We get into a covariance or correlation kind of a matrix easily, and the overall VAR can be computed using the matrix multiplication process directly. So it's very easy in terms of computing the overall portfolio VAR for linear kind of derivative instrument, because you can very well compute the VAR of individual positions the component VAR for each of the positions, and the overall portfolio VAR can easily be computed using the matrix multiplication mechanism. And as long as the deltas can be computed with reasonable levels of accuracy, which we can in case of linear derivatives, we should be able to find the VAR for the overall portfolio quite comfortably. So wherever we see the instruments, as long as they have linearly related kind of a risk factors, a delta normal VAR approach is more and more comfortable to be used. But when it comes to non-linear factors where the non-linear relationships exist, like the options, we cannot directly use the delta because delta keeps changing. Probably for deep in the money options as well as the deep out of money options, the deltas are more stable. So especially at those levels, probably the linear derivatives kind of mechanisms and mappings can very well be applied. But probably at the money options or very relatively in the money or out of money kind of options, they have widely fluctuating deltas, so we may not use a delta normal mechanism for mapping the nonlinear derivatives. You may have to go with a delta gamma kind of a method to compute the overall portfolio VAR if there are options in the portfolio, using the Taylor series approximation mechanisms where the nonlinear or second level kind of mechanism, they are non-linear second degree kind of expressions are typically being used. So probably the forward swaps futures, they can be expressed using they can be mapped using the linear kind of mechanism. So it does not probably when we are talking about option, the delta mechanism cannot provide accurate VAR measures, especially when the deltas are more and more unstable, right? As long as they are stable, it's not a problem. So the delta normal method can be used for option contracts only in those places where the deltas are more and more stable, or probably the range of prices where the deltas are more and more stable, right? Especially when they are at the money, they are very much unstable. When they are very close to expiration dates, when the time to maturity is very small, they are very much unstable. So they don't become, I mean, at least for those kind of options, we cannot use any delta normal mechanism to any extent. But probably deep in the money, deep out of the money kind of options, we can very well think of using the delta normal kind of mechanisms. So that is what I have as a part of the VAR mapping practice, which is more associated with for a portfolio, how do I map the various positions to the corresponding risk factors to which can help us in computing the value at risk for the entire position. All right. Thanks a lot for listening to this session. Thank you very much.